Hello, I'm Laur Hesse Fisher, and welcome back to MIT's Climate Change podcast. Today, I learned climate. When a natural disaster hits a community, the first priority is to get people safe and to save what we can. But after the initial danger passes, the next steps can be confusing. What do we rebuild and what do we change? Could we better protect ourselves in the future? Will the same type of event happen to us again? As our climate changes, these questions are taking on a new level of urgency. Was that storm more intense because of climate change? And how might our response be different if we knew for sure? Our guest is with us today because he is pioneering an emerging type of climate science that aims to give us clearer answers to these questions.
My name is Andy Pershing. I'm the Vice President for Science at Climate Central. We're based here in Princeton, New Jersey, and we do climate science and climate change communication. A big part of what we try to do is tell the local, personal story of climate change. And we often do that through the lens of weather. So trying to look at weather conditions around the country, around the world, and help shine a spotlight on this is climate change. This is what it means to live on a warming planet.
For this episode, we want to make sure that we're really clear that even though weather is closely related to climate, they're actually not the same things. Now, weather is the day-to-day, right? It's the app that you have on your phone that tells you if it's going to rain tomorrow. For meteorologists, this also includes the exciting, tiny details of how a current of warm air brings a rainstorm to a particular town on a particular afternoon.
And a lot of people who get into meteorology, that's what they live for. They love those details and understanding that process. On the other side, you have climate science. And climate science is all about the average. It's about the statistical properties of the weather system.
Our former education specialist, Sylvia Scharf, once gave me a really good analogy for weather and climate. Okay, so think of your wardrobe. The weather helps you figure out what to wear each day, but the climate helps you figure out what clothes to have in your closet throughout the year.
So those worlds had kind of been apart for a long time. And back, when I was in grad school, we were told, you can't connect any one weather event to climate change.
And 10 or 15 years ago, that was true. But now?
We're now in the world where every weather event we have is affected by climate change. And it's really a question of how can you make that link? How strongly can you quantify it? How do we understand the connection between climate change and this extreme weather event?
This is called climate change attribution, the field of science that lets meteorologists say confidently that climate change has made a certain weather event more extreme, and by how much. So what changed over the last 10 to 15 years to make climate attribution possible? Well, we can start with the weather itself.
I think it's not a coincidence that we've started to see more attribution studies as we've started to see more conditions that just could not have existed before, like longer heat waves, more intense heat waves, bigger rainfall events, more powerful hurricanes, hurricanes that do things that they just didn't used to do in the past.
You might be familiar with the concept of trying to hear the signal through the noise. It's like trying to hear a song on a fuzzy radio station. In our case, the weather data, which changes so much from day to day, is the fuzzy static. And the song is the impact of climate change. And as climate change gets stronger, that song, that signal, is easier and easier to hear. But we also need a good radio. And scientists like Dr. Pershing are developing scientific tools to parse the climate signal from the weather noise. So how's it done? Well, we'll start with a kind of weather event that really lends itself to climate change attribution, and that's heat waves.
We have really great data on temperature. So what we will do is look at the history of temperature at a location, and we will look at how the range of temperatures that you're likely to observe at that location have shifted as we've warmed the planet up.
In many places around the world, we have 100 or 150 years of thermometer records. And as you might expect, these data show us that most of the world is experiencing more and stronger heat waves in the summer. But of course, our big question is, how can scientists be sure that that's due to climate change as opposed to something else?
So if you think about, there are other things that we've done that affect the weather. So we've built cities. Cities are hotter, right? We've changed where forests are, and we've turned forests into agriculture. That's going to change the temperature properties. And so we try to account for those changes and then simulate taking today's world with the farms and fields and trees and factories and buildings back into this pre-industrial climate. So let's pick, we're here in Princeton, New Jersey. So what we'll do is we'll look at every day's temperature from 1991 through 2020. So the way I think of it is that we're taking the environment here in Princeton, New Jersey of, pretty close to today of, with I-95s, a few miles that way, and, there are farms over there.
So that allows Dr. Pershing and his team to see how the weather of modern-day Princeton has changed over 30 years of global warming. So if the world warms by 1/10 of a degree, how many more 90-degree days does Princeton get? And how many fewer days of snow?
What that allows you to do is to essentially remove the signal of warming. So now that we know how this particular location responds to a change in global temperature, we can actually turn global temperature off and look at how frequently that temperature would occur if we hadn't put all of this carbon pollution into the atmosphere.
In other words, if you know how Princeton responds to 30 years of global warming without all those complicating factors like new farms and highways, you can extend that to see how it responds to 150 years of warming. And if Princeton gets a heat wave, we can ask two questions. How likely is it for Princeton to see these temperatures today? And how likely was it for Princeton to see those temperatures if we had the climate of the 1880s, before we were strongly warming the planet? But that's not the only evidence that attribution scientists use. They also consult something completely separate: climate models.
I think climate models are absolutely beautiful. I think they're just one of the neatest things that we as humans have built, right? We are able to take the Earth and put it into a computer, and we're able to simulate a lot of really complex dynamics.
Climate models simulate the physics of our climate, how basic laws of the universe, like the conservation of energy and momentum, affect weather features like temperature and air pressure. And they turn those laws into a series of math problems. Computers then solve these problems and recreate weather patterns over decades and across the entire globe.
Some of the first climate models were developed in the 1960s. It really took off in the 1980s and has kept going. And they were part of what allowed us to make a very strong case that humans were warming the planet. I like to say that we're now living in the world that was predicted by those early climate models. And the neat thing about a climate model is that if your model is good, you can add CO2 to it and you can see how much warming you're likely to get. But you can also simulate a world where we hadn't warmed things up. And so you can make these really direct comparisons.
So climate models use data about Earth's physical systems and geography to predict how our climate is and will be changing. Now, this is different from observational studies like our Princeton one, which use real weather data to analyze how our climate has changed. And if we combine both types of evidence, we can start to say something brand new about extreme heat waves. Take, for example, July 2023, when Phoenix, Arizona had 19 straight days of temperatures over 110 degrees Fahrenheit. Now, anyone could have told you that that was unusual, but thanks to this new field of climate change attribution, we can now say something else, that the length and the severity of this heat wave would have been virtually impossible without climate change. In today's world, that is crucial information. It clarifies that we need to go beyond just recovering from these events and to start expecting them.
So our partners at World Weather Attribution work very closely with the International Red Cross Red Crescent, and they are very interested in attribution science because it points to the kinds of conditions that they need to prepare for. They can do things like set up cooling centers and heat action plans, right, which are really important for keeping people safe in hot weather.
And as scientists get better at climate change attribution, they're starting to apply it to not just heat waves, but to all kinds of extreme weather events.
There's really interesting work going on around hurricanes and other kind of major storms like that. You have a number of studies that have started to come out around extreme precipitation events. Lots of studies around drought. And the nice thing about drought, there's not really a nice thing about drought, but the things that make drought easy to attribute is that they tend to be over a large spatial scale, and occur over a long period of time. And so anytime you're averaging over large chunks of space and time, the statistical side of the problem becomes easier.
So research groups have now looked back on, for instance, a severe drought that struck South Africa in the mid-2010s. We always knew that drought was very serious. And now we also know that climate change made it 3 times more likely. Now, wouldn't you want to know that if you were a government official, a city planner, if you sold crop insurance? Heck, even if you were a citizen trying to make plans for your family.
In fact, there's really great survey work that says that people are hungry for this information. People are really curious about climate change. They're concerned about it. So we do a lot of work to help journalists and especially TV meteorologists to connect the things that their local community is talking about to climate change. So, TV meteorologists have this very clear role to play in terms of helping keep people safe and prepared. And then we'll now come in with our more detailed quantitative attribution approaches and say, actually, today's temperature in Phoenix is 5 times more likely because of climate change. We're telling you this is an event that's going to become more likely and perhaps more severe in the future, and that this is something that you should prepare for. It's about helping to keep your family safe. It's about helping to keep your community whole and productive in the future.
That's the end of our episode today, but if there's another aspect of climate science or solutions that you're curious about, we would love to hear from you. Email us at tioclimate@mit.edu or leave us a voicemail at 617-253-3566. We are always excited to hear who you are and why you listen to the show and what questions you have that we might be able to help answer. Today I Learned Climate is a climate change podcast of the Massachusetts Institute of Technology. Aaron Krol is our writer and executive producer. David Lishansky is our audio producer. Michelle Harris is our fact checker. Grace Sawin is our student production assistant. The music is by Blue Dot Sessions, and I'm your host and senior editor, Laur Hesse Fisher. A big thanks to Dr. Andrew Pershing for speaking with us, and to you, our listeners. Keep up your climate curiosity.